Assalamualaikum and hi. For this recorded video, we're going to learn on the topic of gravity retaining wall. Firstly, you have to know what is gravity retaining wall. Any structure that is constructed on the surface of the earth will be pulled toward the earth center. Any structure. So maksudnya apa-apa je because of ada downward acting force yang dipanggil weight of the structure, and also ada gravity acceleration. So when its structure is almost or entirely dependent upon its weight for stability, it may be termed as gravity dependent structure. In our case here, the structure is retaining wall. This is the example of gravity retaining wall. One here you have something that we call it creep wall, and this is gabion wall. There are so many types of wall, but the one that we're going to learn is the masonry wall and also brick wall, reinforced concrete wall. But that one doesn't matter because we're just going to calculate based on the weight of the structure. We need to know what is the failure criteria of retaining wall. It occurs when one of several limit state is exceed. Therefore, factor of safety for each of these limits must be determined. Dia ada limit state maksudnya dia ada factor of safety. Let's say the value yang you dapat nanti, because you need to calculate the factor of safety. Berapa factor of safety daripada the calculation of force yang pull you punya retaining wall and force yang stabilizekan you punya retaining wall. There are 5 limit states: overturning, tension in the joints, bearing on the ground, sliding along the base, and rotational slip. So we're going to look at one by one. So we have overturning. The wall will overturn by rotating some point near the toe. Kat sini if overturning moment of the lateral force, this is lateral force, is greater than the stabilized moment of weight of the wall, this is what will happen. We have toe and heel. For toe, kita panggil dia A. For heel, we call it B. Dia akan rotate dekat A. Means, kat belakang ni, ialah you punya retain material. Anything that you retain. For example, if you retain water, soil, so it's going to be at the back here. A mesti yang dekat depan lah, meaning we call it as toe, and B is heel. Let's say, force here is too much. You know that from force will turn into moment. When force here is too much, it's bigger than the stabilizing moment. Maksudnya kat bawah ni pun ada force juga, because force daripada you punya weight of the wall. Weight of the wall ni ada force. One dia akan pergi arah sini, and another one dia akan pergi macam ni lah. Dia berlawan. This one is bigger, so your wall will overturn sebab dia tak mampu, dia kan melawan. Dia tak mampu nak stabilizekan you punya retaining wall, so your wall will overturn. Factor of safety against overturning is at least 2. FS lah kita panggil. FS is at least 2 Kalau less than 2, perhaps you dapat 1.8, 1.9, meaning your wall will overturn. Next is tension in a joint. If the wall is considered as a vertical cantilever. Okay, so you look at gambar kat bawah ni. Wall is considered as vertical cantilever BC. Superimposed upon the compressive stress induced in the horizontal joint. So horizontal meaning paling panjang lah arah sana kan. Tak kisahlah berapa panjang dia. Upon the compressive stress induced the horizontal joint due to the weight of the wall. Kan ada weight of the wall akan ada bending stress which will tensile along BC. Okay, you have force here. Okay, so kat sini akan ada bending stress. You punya wall akan jadi macam mana? Okay, ada force macam tu. You punya wall akan terangkat meaning to say dia akan lifted a little bit like this. And also in brick or masonry wall, this tension may have effect on the opening of joints. This in may lead to deterioration of the wall fabric. Bila ada forces acting on at the back of the wall here, kan belakang ni akan ada bending stress. Inside here, brickwork atau masonry wall, because you pakai brick kan or masonry, so you akan join it together pakai mortar. Bila you join it together, force ni dia akan deteriorate kan, sebab you punya retaining wall mesti ada opening. Contohnya you letak piping dekat dalam ni lah. Piping untuk water. Kan you selalu nampak kan retaining wall kalau kat tepi-tepi highway, tepi jalan tu. So normally dia akan ada lubang-lubang kat situ. Okay, so this one adalah untuk water seepage. Nak elakkan water seepage so that air akan turun. Masalah ni, dia turun lah. So bawah ni ada longkang lah. Macam tu biasanya. Sorry, the retaining wall will easily deteriorate because of other force. This one yang acting on retaining wall you, and then you ada opening yang ada sambungan-sambungan. Masonry wall you pun bersambung using mortar and so on. So it will lead to deterioration of the wall fabric. We have bearing on the ground. So the combination of downward acting weight, kat sini ada downward acting weight of the wall and overturning moment will set up a bearing pressure between the base and the ground. The maximum ground bearing pressure occurs beneath toe. Failure will occur if applied pressure exceeds the ultimate bearing capacity. You must make sure bearing stress ni is actually stress dekat anything yang connect together. Maksudnya surface tu, for example, retaining wall and soil, dia akan ada bearing stress. Force daripada the back and also downward weight ni will produce bearing pressure. Okay, because of the force kat sini, so kat bawah ni in pressure. With bearing pressure produced by these two forces ni must not exceed the ultimate bearing capacity of the soil. Soil ni boleh support as much as 200 kN per meter square. Banyak ni je. Okay, kalau lebih daripada value ni, bearing pressure produced by the retaining wall exceed this one, meaning this what will happen lah. It will be failed. Because of pressure daripada retaining wall you akan transfer pada soil. So kalau soil you tak mampu support, so this what will happen. And then we have sliding. If the underside of the wall was smooth and it rests on a smooth surface. Bawah ni lah. Okay, smooth je. The wall slide easily along its base. So wall ni akan slide. Okay, macam mana dia slide? Okay, you ada letak force dekat situ, or we call it pressure here. Wall you akan slide. The wall only slide if the lateral face exceed the frictional resistance. RC here is frictional resistance. Kalau P more than RC, so akan jadi sliding. We have a rotational slip. The wall with large amount of the retained mat. Retained mat ni maksudnya tanah Okay, yang you tahan dekat belakang ni. We rotate at center of O sini So ini adalah center of O. If the total moment of the weight of the wall W1 and soil mass ABC, A, B and C exceed the moment of shearing resistance developed along the circular AC. Maksudnya sekarang ni you punya retain mat ni terlampau banyak. Ini akan jadi. Dia akan rotate dekat center O. So you punya wall akan tilt ke belakang because of tanah yang dekat sini dia dah terlebih, so dia akan slip, so dia akan rotate dekat center of O. Ni jangan confuse lah, B ni maksudnya bukan B toe and heel ini masih toe and masih heel. So B ni kat sini maksudnya dia nak tunjukkan tanah tu kat mana, A, B and C. Going to look at the lateral pressure and thrust. Lateral force must be resisted by retaining or similar structure. May result from wind, you have liquid, you have retained granular material. Retained granular material sebenarnya soil lah. Angin, air and soil. Tak semestinya air, liquid can be anything kan, but we call it liquid lah. But normally air lah, dam. Okay, first we look at the wind pressure. The intensity of wind pressure against the side of the structure depends on many factors. For example, average wind velocity, amount of frequency, blah, 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 blah. So there are so many factors contribute to how you going to calculate the intensity of wind pressure. But because it's so hard for you to calculate because there are so many factors, so normally what we're going to do, we're just going to assume it to be uniform. When I say uniform, maksudnya, for example, you have your retaining wall here. For example, retaining wall ni cross section dia macam ni lah. Uniform ni. Tolong lukis supaya you faham benda ni. Daripada top sampai bottom uniform. For example, 10 Newton per meter square. Samalah daripada atas sampai bawah. P is unit wind pressure. Satu ni sebab uniform So darab 1. H ni height of the wall. Kalau heightnya 3 meter then it is 3 meter lah. Because kita assume dia sama for the all height of the wall. A vertical wall of height 3 meters is subject to uniform horizontal wind pressure of 1.2. So this is small p. So jangan confuse because here tadi you nampak ada big P and small p. So big P is wind pressure. Small p is unit wind pressure. Untuk 1 meter square berapa Newton? Itu maksud dia. And then determine the magnitude and position of the resultant thrust per meter length of the wall. You have this formula, 1.2 kilonewton per meter square ni dia punya unit pressure dia. Okay, maksudnya setiap 1 meter square 1.2 kilonewton intensity. Darab dengan 3 meters, the height of the wall. So, you dapat 3.6. For every 1 meter length of retaining wall, it is 3.6 kilonewton. Retaining wall macam ni tadi. So, untuk setiap 1 meter, 3.6 kilonewton. Dia punya wind pressure. Position of the resultant thrust, I sebelum ni explain kan. Because of it's going to be uniform. Position that we're going to take at the punya center. Okay, so center dia going to be here lah, betul-betul tengah-tengah. Bila tengah-tengah, 1/2 darab dengan H. You dapat H over 2 lah. 3 meter height divided by 2 dapat 1.5 meter from the bottom of the retaining wall. Liquid pressure. Dam and other retaining structure are required to sustain a lateral thrust from the retained leaf. Earth retaining wall may also be resist hydrostatic pressure due to groundwater because of dalam tanah ada groundwater juga. But this one kita akan kira later lah groundwater punya sebab. Tapi whatever in liquid pressure that we calculate here, let's say you retain water, for example yang duduk belakang retaining wall dulu lah. Contohnya macam dam or any other retaining structure yang retain liquid To principle of hydrostatic, the pressure at any point of the liquid act uniformly in all direction. You ada liquid droplets here, the act semua sama. So the pressure acting at depth H below the surface of liquid is equal to the product of weight per unit volume of the liquid at the depth. The formula here, so P here means liquid pressure. P ni any pressure lah sebenarnya. Sebab you calculate pressure kan. For this formula lah untuk calculate liquid pressure. How dia dapat formula macam ni? This is your retaining wall. So it retain water at the back. This is dam lah. Dia punya pressure distribution going to be like this. Increase uniformly. You menyelam. You buatlah scuba diving. As the depth increase, the pressure also increase. And we going to assume it increase uniformly. Sebenarnya, value yang dekat bawah ni, berapa pressure yang dekat bawah sekali ni, pressure dia, how you going to calculate PW darab G darab H. So this is the value of pressure dekat bawah ni. This is not PW, this is density of water. Atau unit of water darab dengan H. Bila you nak kira dia punya total pressure dia semua, the whole this thing, so you kena kira dia punya area. Value dekat sini is density of water darab G darab H. Ataupun unit weight of water darab H. Why half? Because of this is rectangle. You're going to calculate the area. Half times density of water times gravity acceleration and times H. So this is H. That's why darab H. Macam you kira area lah. Tengah, ini B, ini D. Darab B, darab D. Sama lah macam ni. Kalau you tengok in the formula, you boleh pilih sama ada you nak pakai density ataupun unit weight of liquid. You know that untuk tukar unit weight dia adalah density darab dengan gravity acceleration. Therefore, when you calculate, jawapan you akan sama je. Let's look at example number 2. A masonry dam of height 6 meter retains water. Therefore, the lateral thrust is water on its vertical face. Calculate the resultant hydrostatic thrust acting on a meter length of a wall when 1. It reached the top of the dam and if it is 1.8 meter below the top of the dam. Right? So, kalau dia reach top of the dam, meaning that kalau height tu 6 meter, wall tu Okay, jadi the water will reach 6 meter lah. And for B, meaning that 6 meter minus 1.8 meter. Okay, and given here the density of water is 1 kilogram per meter cube. It means that density-nya adalah 1000 kilogram per meter cube. And this is the standard Maksudnya ini tak berubah lah, memang sentiasa 1000 kilogram per meter cube. Kalau soalan tu tak bagi, dan kita sebenarnya dah tahulah memang water the density is 1000 kilogram per meter cube. So how we going to answer this one? Okay, as we know, there is two formula for pressure untuk water. So pressure equal to half times the density of water times gravity acceleration times the height of the water, power of 2. Or you can also use half times unit weight of water times height of the water, power of 2. So you boleh pakai mana-mana formula here because kita tahu water pressure. Okay, for example, you have a wall like this. Okay, so the retained water at the back. So this is A, this is B. The pressure distribution is going to look like this lah, macam triangle kan. So value here at the very bottom here, it is density of water times G, H, okay, ataupun unit weight of water times H. Benda yang sama, and that formula kita dapat daripada this distribution triangle, which is half because of area of the triangle. Half ni adalah triangle, darab dengan unit weight of water darab G darab H ni. Okay, sebab ini macam dia punya lebar lah. And the height dia adalah H kan. Therefore, density of water darab dengan gravity acceleration darab height lagi. That's why dia jadi power of 2. Ataupun if it's like this, then macam ni lah. Okay. So kita boleh pilih salah satu, doesn't matter. But here, I pakai this one. But then, I kena tukar the value of density of water kepada unit weight of water instead supaya saya boleh masuk dalam formula ini. Okay, tapi kalau you nak directly pakai this formula, yang ini pun tak ada masalah, sama sahaja. So unit weight of water equal to 1000 kg per meter cube. Okay, you know that density kita nak tukar kepada unit weight. Okay, kita kena darab dengan gravity acceleration. Okay. And bahagi dengan 1000 sebab kita nak tukar ini daripada kilogram pergi ke Newton. And ini daripada Newton nak tukar tu kilonewton. That's why bagi dengan 1000. 10 kilonewton per meter cube tu pun fix. That is the unit weight of water. If it's not given, then you know that is the value to unit weight of water. Then we have the formula here. So I pakai formula ini. Use the unit weight. So half times unit weight of water, which is 10 kN per meter cube, times with the height of water. Okay, because it reach at the very top of the retaining wall. Maksudnya memang setinggi retaining wall tu lah, which is 6 meter. Then power of 2. So this is the value yang saya dapat. Kilonewton per meter meaning untuk setiap 1 meter panjang wall ni lah, sebab wall ni kan panjang ke sana, jadi untuk setiap 1 meter panjang the retaining wall. We have another question B, right? And for B, apa yang tak sama hanyalah the height of water itu sendiri, which is it says that it is 1.8 meter below the top level of the retaining wall. Okay, maksudnya 6 meter kena tolak lah dengan 1.8. Perhaps it reach up until this level only lah. Okay, so 1.8 meter ke bawah daripada 6 meter tu. So that's why jadi 88.2 kilonewton per meter. Right, so That's on example 2. Now we look at example 3. So example 3 is almost sama saja. Okay, a masonry dam retains water on its vertical face. The wall is as shown in figure 3.7 meter, but the water level reach only 0.7 meter from the top of the wall, meaning sampai 3 meter sahaja. What is the magnitude and the position of resultant water per pressure meter run of wall? Right. For this one, dia tak ada mention about the density, so you are free untuk pakai formula pressure untuk water yang pakai density ataupun yang pakai unit weight. Okay, so I nak senang, I pakai yang unit weight lah sebab kita tahu the unit weight of water it is fixed 10 kilonewton per meter cube. Therefore, I just use this formula like this. Okay, so pressure dia segitiga lah. Okay, sebab ini adalah water. Height dia adalah 3 meter, height of water, not the height of retaining wall. Okay, then I get the 45 kilonewton per meter. And the position of the resultant truss, since the question asks you to find position dia. So position dia dari mana? So dia mesti daripada bottom of the retaining wall, daripada bawah. So it is 1/3. Why? Sebab you know that the distribution of pressure look like this. Then you know untuk water it is triangle. Okay. Okay, bawah ni dia adalah 1/3 daripada H. 1/3 jarak dia. Okay. Kalau dari atas, okay, it is 2/3H. Tapi kita bukan nak dari atas, kita nak dari bawah. So 1/3 darab dengan H. Kenapa kita ambil jarak ni, bukan jarak ini. Okay. Memang tak pakai jarak ni lah sebab apa? Force tu, okay, pressure-nya tu, dia adalah horizontal pressure. So kalau kita kira moment, kita akan ambil jarak yang 90 darjah daripada force itu. That's why it is 1/3 times H. 1/3 times H, it is 3 meter. So you dapat 1 meter from the bottom of the retaining wall. Next is pressure due to retained soil and other granular material. Soil, unlike liquid, are not usually uniform. Differences properties from one layer to another. The whole layer of soil, bukan daripada top to bottom, jenis soil dia adalah sama. So different properties. If quantity of each of such material was dipped on the flat surface, it would flow out to form a conical heap. Let's say you ada soil, you genggam dengan tangan you and then you release the soil sikit. Dia akan jadi macam ni lah. Soil tu jatuh, dia akan naik jadi conical heap. A more reliable measure of internal friction of the soil is obtained by testing the soil in laboratory. Kenapa jadi macam ni? Because soil tu sendiri dia ada friction because of each particles dekat dalam soil tu. Dia ada different texture. Dia berlekuk-lekuk, bersegi-segi, different shape and texture. Dia akan provide friction resistance pada the soil itself. Because of dia ada surface resistance, kan? There is a friction. How are you going to measure it? Nak more reliable dekat dalam lab lah. But other several useful theories exist. However, it will be sufficient to consider Rankine's theory. We're going to use Rankine's theory untuk measure the friction yang produced by the surface of the soil. So ini adalah assumption daripada Rankine tadi. Materials is incompressible, homogeneous, satu jenis, granular, cohesionless. So bukan cohesive soil. This one lebih kurang pasir. Pasir is cohesionless soil. That possess internal friction resistant to movement between grains. If the quantity of such material was dipped into flat surface, it would form a conical heap. This is what I told you before. So dia akan jadi naik macam conical heap. The material within the cone support itself due to internal friction because of other friction between the surface of each particles. The angle of side of cone is known as angle of repose. Ini namanya angle of repose ataupun angle of shearing resistance. Kita panggil as theta. Liquid do not possess internal resistance to shearing. The angle of shearing resistance for liquid is 0. So liquid tak ada angle of shearing resistance because if you pour liquid in bekas ke apa, it will actually ikut shape of that particular bekas. Jadi dia tak ada shearing resistance ataupun dia tak ada angle of repose. In frictional materials, the lateral pressure exerted somewhat less than the vertical pressure. In Rankine theory, the ratio between the lateral and vertical pressure evaluated in terms of the angle of the shearing resistance. So Rankine theory of lateral pressure, this one for granular material ataupun soil lah. P is equal to half Ka unit weight H times H. So kalau you notice, formula lebih kurang sama, cuma ada additional Ka kat sini. Ka dekat sini adalah Rankine theory. So what is Ka? Ka ni tadi, you nak calculate the friction tadi tu. Maksudnya resistance to shearing tadi. You look at the formula here. 1 minus sin theta. Theta here meaning angle of shearing resistance ataupun angle of repose tadi. The unit weight here adalah unit weight of soil tu lah. Unit weight of granular material. H here means height of soil. For example, you tanam sampai sini. This is the pressure distribution. Sama juga macam liquid. Dia segitiga uniformly increase. Where is the centroid? The centroid going to be here. 1/3 times H. Kat sini juga dia punya pressure distribution centroid guys. Tadi I'm talking about the formula. This is value of Ka unit weight darab dengan H. How you get the pressure? You kira area dia setengah because of this is triangle times Ka unit H darab dengan dia punya height lah. K darab H. Let's say dalam question dia tak bagi unit weight. Dia bagi density macam ni. So sama juga. This is density darab dengan gravity acceleration. So you boleh convert pada unit weight or you can calculate terus dalam ni pun boleh juga. But don't forget to divide by 1000 because you need to convert from Newton to kilonewton. Since the PA varies uniformly with depth of ridges, so the pressure distribution diagram for lateral pressure on AB is a triangle. We're going to look at example number 4. Soil weighing 15 kilonewton per meter cube. This is unit weight of soil. And having an angle of repose of 30 degrees. This is theta, angle of repose. Exerting pressure on 4.5 high vertical force. What is the resultant horizontal force per meter run of the wall? Memang tinggi soil tu 4.5 sama macam retaining wall itself. So this is H. The value of Ka first because this is to calculate the shearing resistance. Ka equal 1 minus sin theta plus 1 plus sin theta. Tadi formula tadi Masukkan the value of 30 degrees as the angle of repose. Atau bila you kira ni you dapat 0.5 over 1.5 if I'm not mistaken. So sama kan? Ataupun kalau you calculate directly, maksudnya you calculate, you tak buat dalam bentuk pecahan macam ni, you buat dalam bentuk decimal, so you dapat 0.333. You're going to calculate the pressure due to retained granular material. 1/2 times Ka times unit weight of soil times H. 1/2 Ka calculated 1/3. 15 the unit weight of soil. H is 4.5. The height of soil. I dapat 50.625. The next question, we're going to look at example number 5. A masonry wall with a vertical back 6 meter high retains earth having a density of 1960 kg per meter cube, an angle of shearing resistance of 30 degrees, meaning this is theta, and this is the density of the soil. Calculate the active lateral thrust acting on the wall using Rankine's theory. Right, so this is what the question gives you, and 6 meter is the height of the wall. And actually, the soil reach up until the very top of the wall. Right, so how are we going to answer this? First, since we know this is the soil, meaning that there is a Ka there, and we already have the value of theta according to the question. So you can either use 1/3 or you can just calculate kalau ada perpuluhan 0.33 pun betul, sama saja jawapan. Untuk calculate the pressure, okay, so you have two options whether you nak pakai this formula. Ka, density of soil, darab G dan darab H, power of 2. Ataupun setengah darab Ka, unit weight of soil, darab H power of 2. Sama sahaja, but don't forget kalau you dapat guna density, darab dengan gravity acceleration jangan lupa bahagi 1000 lah, sebab di dalam Newton you kena tukar kepada kilonewton. Okay, sebab pressure distribution yang macam ini as what I have explained, and value di sini adalah Ka, density of soil, darab H, ataupun Ka, unit weight of soil, sorry, di sini ada darab G darab dengan H. Okay, so mana-mana formula sama saja you boleh pakai. And for this one, I use this formula. But the density, sebab dia bagi density of soil, therefore kita akan tukar that density to unit weight 1960 kg per meter cube given. Then you have to times with the ini adalah density of soil. This is the gravity acceleration. And bahagi dengan 1000 sebab kita nak tukar from Newton to kilonewton. Then I get 19.6. This is the unit weight of soil. And you can just masukkan je dalam this formula which is half Ka unit weight of soil times H power of 2. Ka, we already have the value 1/3 or 0.33 if you use that, times with 19.6, that is the unit weight of soil, times with 6 meter, that is the height of the soil, sebab soil to reach the top of the retaining wall punya level. Then I get 117.6 kilonewton per meter. Maksudnya untuk setiap 1 meter panjang retaining wall ini, itulah dia punya pressure yang the retaining wall ni kena pada dia lah. Now we look at the next one which is step wall faces. So sebenarnya kalau retaining wall you macam ni ke, step dia dekat bahagian yang you retain kat sini ada retain material. Remember ini A, ini B. This is toe, this is heel. Heel mesti dekat belakang. The lateral pressure is assumed to be abnormal to the supporting structure. Therefore, the direction of this pressure will be horizontal. Sama je. Macam mana you kira for the yang wall yang I tunjuk. Contoh straight kan. Doesn't matter the step sekalipun. Here we have inclined wall faces. Okay, but don't confuse. Kenapa macam ni? Okay, so sebenarnya ini A, ini B. Kita balik dia lukis. Ini heel kat sini. Because of retained material is at heel. Material akan duduk behind the heel side of retaining wall. So ini bahagian front side dia. Ini belakang This is L. The formula is P pressure is equal to half times PA times L. PA here, you nampak kat sini dia tulis small p. Small p is not density Sebenarnya tadi kalau you perasan, value ni KAH adalah small p. Ini adalah pressure juga. Pressure at that point. Pressure at this point. Kita nak kira total pressure untuk tinggi ni. So, we need the value of pressure at the point yang paling tinggi, which is yang dekat bawah sekali untuk calculate area dia. This is small p. Okay, sama juga. Kalau liquid tadi, formula dia 1/2 darab unit weight of water darab H kuasa 2 kan. Ataupun setengah 1/2 darab unit weight of water H darab H. Ini adalah small p. Ini semua adalah p besar. This is for liquid pressure. In the inclined wall faces, so P2 adalah that small p. Okay, small p sama dengan, let's say it retain water. Kalau retain water, unit weight of water darab dengan H. This is for liquid And if it retain soil, small p dia adalah, kalau you kira the big P, maksudnya the total pressure dekat semua tu, pressure distribution semua tu, kira area dia kan, setengah darab unit weight water H. So darab dengan, you nampak kat sini PA darab dengan L. L ni adalah sloping height. So maksudnya mana? Ini. Okay, so condong ni, panjang condong ni berapa? Darab dengan L. Sama juga big P for this is tengah darab KA for sol darab H darab dengan L juga. Effect of surcharge. Okay, when the superimposed pressure is applied at the surface of the retained soil, the active lateral pressure is increased by the proportional amount. Superimposed pressure ni apa maksudnya? You have a retaining wall here. Contohnya belakang ni is soil. So you pun binalah satu bangunan kat sini. This bangunan adalah surcharge. Beban tambahan, extra. This is superimposed pressure. Kalau setakat orang seorang berdiri kat sini, kita tak anggap dia superimpose. Berapa sangatlah loading daripada this particular person compared to a building. Symbol for surcharge is PAS. Sama juga masih lagi pakai KA. Okay, kenapa KA? Because of surcharge only ada dekat soil. Retain granular material. Surcharge tak ada dekat water. Water is not like soil. Soil dia, let's say you put anything on top of the soil, soil tu akan mampat kan, how to say. Kalau water dia akan melimpah dia keluar. Kalau you letak boat tu akan float. Dia bukan terus masuk ke dalam, tenggelam dan menjadi satu yang mengganggu dia punya loading kat situ. Ini only effect pada tanah saja. So KA times Q. Q ni is surcharge pressure and then times dengan H. H ni height of soil. The total of overturning moment is the sum of moment of PA and PAS. If you nanti you kira overturning moment, you kena kira moment that caused by the pressure due to the soil itself, and then let's say there is a surcharge ataupun superimposed pressure, you must include it masa kira overturning moment. Now, let's look at example number 6. Determine the active lateral thrust acting on the retaining wall described in example 5 if there is also a surcharge of 20 kilonewton per meter square acting on the surface of the soil. This question asks you to find the active lateral thrust, meaning that it is not only the surcharge yang act dekat wall tu, the pressure of the soil pun kita panggil dia as active lateral thrust. Anything yang try to overturn the retaining wall, any pressure, okay, dia termasuk dalam active lateral thrust. So sekarang yang try nak overturn the retaining wall, it will be the pressure due to the soil and pressure due to the surcharge, which is PA, which is this one due to soil, and PAS, this one adalah surcharge. Right, so dia minta you refer pada example 5 for more information untuk example 6. First, kita akan kira surcharge dulu, okay, which is PAS, KAQH, that is our formula. And for KA, this is where we're going to refer to the example number 5. And also H, 1/3. And the value of H, 6 meter. Okay, so itu information yang kita nak. Fill into the formula. 1/3 is the value of KA. And 20 km per meter, this is from the question itself. And the value of H daripada example number 5 juga 6 meter. And you get the total of surcharge is 40 kilonewton per meter. And since this question want you to find the total lateral thrust, meaning that you need to find PA and PAS. Right, so mana you akan dapat PA? So ini dari example number 5 because this question is based on example number 5. This is example number 5. So ini kita dah dapat PA dia 117.6. And plus with the value of PAS. There you go. That is the answer. That's all for now. See you again in the next video.